In this video, we've got a couple examples. The first expression right here, we're going to be adding and subtracting radical terms, and we can't add and subtract them as is right now because none of them have the same radicands. And the radicands would be the numbers or variables. In this case, they're numbers. They need to be the same, and those are the radicands. So they're not. So let's try to break these down and make them in the simplified form. Square root of 12, we ask ourselves, what perfect square divides into that, if any? Well, 4 is a perfect square that divides into 12, so we do the square root of 4 times the square root of 3, and that gives us 12. Plus, 49 is a perfect square that goes into 147 evenly, so we do the square root of 49, and then times the square root of 3, minus 108. So now what perfect square goes into 108? And that's going to be 36. And you can divide 36 into 108. I believe that is going to be 3 times. So then we're going to have the square root of 3. Okay. Now let's simplify. Square root of 4 is 2 times the square root of 3 plus the square root of 49 is 7. And then that's times the square root of 3. Minus the square root of 36 is 6 times the square root of 3. Now we have the same numbers under the radicals. We have a 3, a 3, and a 3. And now we could add together the values that are in front of the radicals, which would be a 2, a 7, and then the negative 6. And you could treat the radicals just like if you had variables. So like imagine if you had 2x plus 7x minus 6x. How many x's total would you have? Well, 2 plus 7 is 9, and then minus 6 is 3, so you have 3 x's. So you'd ask yourself over here, how many square root of 3's do we have? So 2 plus 7 is 9, and then minus 6, we'd have 3 square root of 3's, and that would be our final answer. Now in this expression, we have numbers in front of the radicals, so that's the only thing that's really different, but we still have to add and subtract them together following the same rule. So none of the radicands are the same, so let's break them down now using perfect squares to see if we can get radical terms that do have the same radicand. So what perfect square goes into 50? That's going to be 25. So I'm going to rewrite the 2, but then I'm going to do the square root of 25 times the square root of 2, because 25 times 2 gives us 50. Then we've got minus 5, and then the perfect square that goes in 18 will be 9. So we do the square root of 9 times the square root of 2, and then plus 6 times the perfect square that goes into 32 is 16. So I do the square root of 16, and then that's times 2. So I'm going to simplify this stuff. So we've got 2 times the square root of 25, which is 5, and then times the square root of 2, we can't break that down at all, minus 5 times the square root of 9 is 3 times the square root of 2, plus 6 times the square root of 16 is 4 times the square root of 2. Continue to simplify. So we've got 2 times 5 is 10 times the square root of 2 minus 5 times 3 is 15, so that's times the square root of 2, plus 6 times 4 is 24 times the square root of 2. So now how many square root of 2's do we have? Because this, and this are all the same. We've got the same radicand, so that means we could add or subtract, whatever terms are in, or whatever values are in front of those radicals. So 10 minus 15, that's going to be negative 5, and then negative 5 plus 24 is going to be a positive 19, and then that's times the square root of 2, and that is our final answer.